Right. Good evening, everyone.
Hi, Arni. Good evening.
Hi, Kalpesh. Okay. All right. So we'll be starting off in a minute. So, guys, sorry. So, today's session is basically more or less on application control. A little bit of theoretical session. So, we will be maybe we'll be starting off with the practicals tomorrow because a lot to cover on the concepts and the working behavior and all that stuff. So today will mostly be a theoretical session. Maybe if I'm able to complete all that, then I'll probably start off with the practical. But then if not, then tomorrow we'll start off with the practical. So application control will start off with the what exactly the application control is, what are the types, and implementation scenarios, and how do you troubleshoot those kind of issues and all that stuff. So we are going to talk about all those things today. Okay. All right. So give me 1 minute. We'll start off by 6:04, maybe 6:05. Okay. All right.
I have followed that process which is given in PDF.
Mm-hmm.
I'm trying to open the external IP, but it's not opening.
For the GCP.
Yeah, GCP.
Okay. Are you able to take the SSH session? Is that working?
SSS that command line window is opening actually,
Hmm.
but if I'm trying to open the
Hmm.
external IP
Hmm.
through HTTP, it's not
Hmm.
opening actually.
Hmm. Okay. Right.
Uh, and in that PDF, they have not given to select the EVNG file.
To select
Uh,
EVNG.
EVNG file in that PDF, and
Uh-huh.
if I refer that video, in that he has selected EVNG file. So I don't know why.
So no
If,
worries. I'll if it is okay, I'll probably take a remote of yours machine. Maybe tomorrow morning. Is that okay?
yeah, yeah, okay.
Okay. All right. Maybe by 9 o'clock. Just remind me on the group.
Yeah, yeah, sure.
Okay. All right.
Yeah, hello. Yeah, Raufuddin here.
Yeah, Rafaddin, tell
Yeah,
me.
yes, I'm facing problem that as you said, Windows 7 update the Firefox I updated. After that,
Uh-huh.
connect back to Windows Fortinet interface to
Mm-hmm.
Windows 7, but it's still not getting the IP Windows 7.
Okay. No, so once you connect to the interface of the Fortigate firewall, you'll not automatically get an IP. You have to configure an IP on
Static
the
IP.
yeah. So if you have port 2 connected to your Windows 7 machine, what
Yeah,
port is connected to the internet or the net IS cloud that you have?
port number 1.
Port number 1. Okay. So
Yeah,
port 1 is by default DHCP in Fortigate firewall. So if you
yeah,
go into the CLI, you will be able to see
yes, yes, I can
you're
see.
able to see. Yeah, great.
Yeah.
So configure a port 2 with any IP address and same IP address range in the Windows 7 machine, and in the gateway section of the Windows 7, just put the IP address of the FortiGate firewall, whatever you have configured. That is it. Then you will be able to, log in with the web GUI.
Yeah, yeah. And what about the DNS? Default
DNS
data.
in the Windows 7, put the DNS as 1.1.1.1 or 4.2.2.2. Okay.
data is okay.
8.8 is also fine. You have to create a firewall policy, okay, which will be allowing the traffic from port 2 to port 1. Make sure the DNS is also allowed. That is it. So once the traffic starts flowing through the firewall, you would still be able to access the internet. You will still be able to access everything.
I assigned the static IP in the Windows 7, but the policy I think I have to do in that.
Yeah, you have to do one thing. I'll make it easy. So configure port 2 with an interface, with an IP address. Okay. Now in the same range, you put an IP address on your Windows 7 machine, and in the gateway section, put the IP address of your FortiGate firewall, port 2. Okay. Once you do that, go ahead, open up a browser and log in with the web GUI. You should be able to log in.
Can you
If
tell me
you're,
the command for port 2 configuration in the Fortigate?
it's in the videos. It's in the videos. If you check those, you'll find all these steps are there. We have covered all these things: how to log into the web GUI, how to configure the interfaces, how to configure the firewall policies. Everything is there. Okay. So go through that. If in case you still feel you're getting stuck somewhere, let me know.
again I have to see the video. If you have command, I can do fast. I open the lab now. That's why.
Okay, quickly type in config system interface.
Config. Sorry, can you repeat
System
it? Config system.
interface. Enter.
Yeah. Yes.
Edit. Space
Okay.
port 2.
Yeah. Yes. Port
Enter.
2 I have to type only.
Yes, you have to type port 2. Or even
Port
type
one.
if
Yeah. Enter. Yes. Done.
set IP.
Yeah. Can I type the IP? Range, same range.
Whatever IP that you want.
Free IP. Yeah. Subnet marks also.
What IP have you given?
192.168.137.140.
Is this the same range of your EVNG?
Yes.
Please do not. Give another. Okay, give set IP 10.10.10.10.
Yes.
Okay. Space. Oh, sorry. /24.
Yes. Given. Enter.
Okay. Now set allow access.
Yes. Yeah. Set allow access.
HTTP space HTTPS space ping
Yes.
space SSH.
Yes.
Enter.
Error coming.
Done.
No. Allow access. Yeah, error 61 I am getting.
Meaning you might have not typed in the right syntax. Can you tell me what is the syntax you have to put in?
Set allow access HTTP space HTTPS space ping space SSH.
Do you have a space after set allow access?
The number you have.
Yeah. Set allow access space after that HTTP, HTTPS, ping and SSH.
All of them I have spaces, right?
Yeah.
Okay, I'll make you the co-host. You can share your screen.
Either and I screenshot I copy in the your chat section. That will WhatsApp. Allowed.
So allow access is not two words. Allow access is just one. So remove the space between allow and access.
Yeah, it's got it now. It's okay now. So shall I try in the Google Windows 7 Chrome Firefox? Save anything required?
Type in end to save.
END, correct? Yeah, it's done.
Now use the same IP address, same IP range, any IP 10.10.10. Maybe 50. Put the gateway as the interface IP address. That's it.
That.
Yeah. Okay. All right.
So I can ping from the Windows 7 to the Google Internet. Shall I ping that internet from the Windows 7?
It will not work. You have to create a firewall policy for that first.
Okay.
Yeah. Okay. All right. So now go ahead, check the videos. You have information over there. You will be able to create the firewall policies, and then you will be able to ping anything from your Windows machine. First, make sure that once you configure an IP address on your Windows 7 machine, just see if you're able to log into the web GUI of the Fortigate firewall. Okay.
Yes. Okay.
All right, guys. So coming back. Yes, Sunit.
Are we starting?
Yes, we are going to start now. Okay. So, all right, guys. So today's topic, as I already informed, so today's topic would be application control, and we are basically going to talk about the concepts, behavior, scenarios, and how exactly you go about troubleshooting the application control, right? And tomorrow we'll start off with the practicals of this. Okay. All right. Okay, so I'll probably I'm going to mute you for now. Okay, I'll unmute all of you maybe in the next 20-25 minutes, and if in case you have any questions and challenges, you can put it in the chat box. All right, so I'll probably unmute you maybe then. Okay, so I'm muting you guys right now. Okay, all right. All right, so we are going to talk about something which is called as application control. All right, now see, just to give you an idea, so after completing this section, okay, you should be able to achieve the objectives shown in the slides, right? So understanding the application control, detection types of application, understand the FortiGuard application control services database, and using the application control signatures. Okay, so this is what we are going to understand by today's session. Okay, now let's talk about what exactly is this application control and how does this thing work, right? So see, application control basically detects applications, okay, often applications that consume a lot of bandwidth, okay, and allows you to take appropriate action related to your application traffic, such as monitoring or blocking or applying traffic shaping. Okay, so traffic shaping is just like bandwidth control. Now, application control identifies applications such as Google Talk by matching there are known patterns to the application's transmission patterns. Okay, therefore, an application can be currently identified only if its transmission pattern is unique. Okay, so whenever we are talking about transmission pattern, whenever we are talking about signatures, right? So basically, it's the same thing which we were talking about in the IPS session as well, right? Because the signatures is basically the same, the usage is different. So now in the application control, the usage is different, signatures still the same, transmission patterns still the same. Okay, all right, now not every application behaves in a very unique way. Okay, so many applications reuse a pre-existing or a standard protocols, just like TCP 443 or 8T or IPsec VPN. So these are basically pre-existing or standard protocols, right? So this is how every application works in the network. All right. For example, many video games such as your World of Warcraft is quite famous, right? So they use protocols which that they basically use the bit torrent protocol to distribute the game patches, like a point-to-point or P2P protocols. Okay, now application control can be configured in this proxy-based and flow-based. Both of them are possible. However, because application control uses IPS engine, as we discussed already, okay, which uses flow-based mechanism. Okay, so IPS engine by default uses the flow-based inspection. Okay, and inspection is always flow based. Okay, so by comparison, when applying web filtering and antivirus through an HTTP proxy, the proxy first parses the HTTP, removes the protocol, then scans the payload inside. Okay, that is how it works. Okay, now why does Fortigate use a flow based scan for application control? I mean, genuine question, right? Why does the Fortigate uses a flow based scan for application control? See, unlike other forms of security profiles such as web filtering or antivirus application control is not applied to a proxy. Okay, it uses the IPS engine to analyze the network traffic to detect application traffic. Okay, that hence the word application control, right? So it uses the IPS engine to analyze the network traffic and detect application traffic, even if the application is using standard or maybe non-standard protocols or ports. Okay, I have full rights to use port 80. I can also use port 8080. That's up to me. But the pattern of the HTTP protocol still remains the same. Is what has changed is the port number. That is it, right? So it doesn't operate using the the built-in protocol state. It matches patterns in the entire byte stream of the packet and then look for patterns. Okay, so again, as I said, that when the the signatures are created, right, the signatures are created on the basis of what protocol is or what the port information or what the the behavior is. So I think we discussed this when we were discussing the IPS as well, that if it is a TXT format, it has a different behavior. If it is a music file, it has a different behavior. If it is video file, if it has a different behavior. So the application control also has the same signature database, right? What it does is that regardless of whatever the protocols that you are using, it is going to find that what pattern the traffic is going, and according to whatever the pattern the traffic is going, it will match the signature database. Okay, so it has, as we said, that IPS database will be used over there. Okay, all right. Now, detecting peer-to-peer applications. So the P2P is basically required, used a lot. Okay, so when the HTTP and other protocols were designed, okay, quite back, so they were designed to be easy to trace. Because of that, administrators could easily give access to a single server behind NAT devices such as router or firewall, whatever. So that is why the HTTP protocol was designed. That is how it was designed, so that it can be tracked, it can be traced easily. Okay, because I mean, those days the network was not so complex. There was no such attacks and everything which we have right now. Those were basically simpler times, to keep it very simple. Now when these P2P applications were designed, they had to be able to work without any assistance. That's why it was called as P2P, peer-to-peer. Okay, so that is how they were designed, so that they are able to work without any assistance or cooperation from whatever network administrators were there at that moment of time. So in order to achieve this, the designers, what they did was they made the P2P applications to bypass the firewalls and incredibly hard to detect. Okay, now port randomization, Google this, port randomization, pinholes, and changing encryption patterns are some of the techniques that P2P protocols use. Okay, so if you go a little bit deep into it, you will be able to find that the port randomization, instantly changing the ports on the requirements, and pinholes, and changing encryption patterns. Some starting off, maybe I was using DES, then I quickly changed it to 3DES. So basically just changing the patterns, changing the behavior as much as possible, just to avoid detection. Okay, now these techniques make your P2P applications difficult to block using a firewall policy. Okay, and also make them difficult to detect by a proxy based inspection as well. The flow-based inspection, using the IPS engine, can analyze the packets for pattern matching and then look for patterns to detect the P2P application. So now what happened was just to give you a historical lesson, quite small one. So this is how the P2P was designed. Now slowly and gradually, people started noticing that if in case we are using P2P, it is very hard to determine what exactly it is and how to identify and all that stuff. So for those times, it was very difficult for any security device to identify that. So slowly with the passage of time, we understood the behavior, the pattern, the way it behaves in the network, how it connects to the network devices and all that stuff. So slowly signature database for P2P connections started to evolve. Okay, and now every P2P application is easily detectable because on the basis of whatever the behavior and patterns we have learned through all the years, right? So let's understand that if in case whenever we are going through such kind of applications like Skype, okay, or BitTorrent, those are basically a classic example of peer-to-peer applications, right? So this is how exactly the P2P infrastructure works, and what is the behavior of it. So if in case somebody asks that what exactly the P2P is all about, this is how you can talk about it. All right, okay. Next, client server architecture, one of the most famous architectures all over the world, right? Because that is the first thing which we normally understand and which we learn whenever we are basically getting into the networking department, right? So client server architecture, let's talk about this. See over here, it basically shows you a traditional client server architecture. There may be basically there may be many clients of popular sites, but often such as with an office file server, maybe just one client, maybe 3 users or 4 users, or maybe just one server. Okay, these are the the classic examples when it comes to the client server architecture. Traditional downloads use a defined protocol. Okay, so always remember that the traditional downloads use a defined protocol over a standard port number. Okay, very simple put. If I need to download anything, I'll probably open up a browser, I'll go to the file, maybe whatever the hosting service that I'm going for, maybe download.com. Okay, and I'll go into that particular website, I'll download whatever software that I need, I'll click on it and I'll start downloading. So what I'm using the HTTP protocol over SSL, that's it, 4443. So it's basically a traditional way or a classic way of downloading any file over the web, and it's a standard protocol number 443. We are still doing that. It's not that we have it's changed in the last 20 or 30 years. It's still the same. So whether it's from a web, okay, or an FTP site, the download is from a single IP to a single IP. Okay, always remember that if you look closely, whenever we are downloading anything, it is always from a single source IP, and it is always with a single destination IP. So blocking this kind of traffic is easy, very easy. You just need a firewall policy, that is it. Put a source, put a destination, block it, and that's it, right? One of the most simplistic architecture, as I said. So but it's more difficult to block traffic from peer-to-peer downloads. Why is that? Okay, see, when we are talking about the peer-to-peer, okay, let me show you, hold on. So peer-to-peer architecture, why is it difficult? Why client and server is simple and why peer-to-peer is difficult? See, peer-to-peer or P2P downloads divide each file, okay, among multiple and theoretically unlimited. Okay, although not technically possible, but then theoretically you can have as many peers as you want. So what it does is P2P downloads divide each file among multiple peers. Okay, now each peer, as you can see over here, each peer delivers a part of the file. Okay, while having many clients is a disadvantage in a client and server architecture, it is an advantage for a P2P architecture, because as the number of peers increases to whatever number, the file is delivered that many times faster. Okay, so I just to give you an an idea that I used to have so basically so I used to have the BitTorrent software. Okay, there was a time when I had the BitTorrent software. What I used to do was always try downloading maybe some movies or whatever movies was coming in, or whatever software I wanted to pirate it, software and all that stuff. So there was a fad 10 maybe 10 12 years back I had that I have to download a lot of things. So those were the days for me. So anyway, my point over here was that I had this software which is called as BitTorrent, okay, which you can see over here, but I never had an idea that how exactly this worked. What I knew was that there are certain things which is called as peers, okay, and then there was something which is called as seers. Okay, so what I knew that was that the number of peers, as many number of peers, so if the number is increasing, that means my download will be much faster. Okay, this is what my basic understanding was. Now slowly and gradually, when I came into the networking and all, I got to know about these architectures. Then I got to know that okay, it's like if I have a 10 GB file, right? So those 10 GB file, maybe 1 GB is distributed to each one of them. Okay, now whatever the download connections are being made, all right, so what happens is one machine having a download of 10 GB and 10 machines having multiple 1 GB files, again it's quite faster. You might have heard about a software which is called as DAP, downloader accelerator plus, right? So what it does, what this was also doing the same kind of mechanism where it basically divides the file into multiple small segments, and then download those small segments and then compile the file again to make it one single file. So the point over here is that peer-to-peer architecture works on the basis of the number of peers that you have, how many number of nodes you have. You can call them as nodes, you can call them as devices, okay, system, whatever you want to call them. Basically the meaning is still the same. Okay, so one thing more, so number of peers, so whatever the number of peers, that is the number of speed that you will get. So as many more numbers, that will be the amount of speed that you will get. Okay, now because the popularity increases the speed of delivery, unlike traditional the client server architecture, where popularity could effectively cause maybe a DOS attack on the server, right? Because if I have just one server and I'm trying to download everything from here, if there was a DOS attack over here, okay, and this system is down, gone, I lost my connection, and I do not have any other way to download that file until this system comes back, right? So now with the peer-to-peer architecture, it doesn't matter, even if the system goes down for some reasons, I still have multiple peers through which I would be able to download that file. Okay, so that is the system and that is how it works. Okay, all right. Now, in order to download the file, the requesting peer can consume much more bandwidth per second than it would from a single server. Okay, even if there is only one peer in your network, it can consume unusually large amounts of bandwidth because the protocols are usually evasive. Okay, they will try to evade itself, and there will be many sessions, many peers which are difficult to block, right? So that's the whole point of having a peer-to-peer architecture. Okay, too many nodes, small connections, and every connection is making some bandwidth utilization. So very difficult to pinpoint and very difficult to understand that is it legitimate or is it not legitimate, or is it what exactly is happening. Okay, so that is how the architecture works. This is how the P2P architecture works. Okay, now let's talk about this is always about the architecture. Now we are going to talk about the applications control, the signatures. Okay, how these signature works and how do you basically fix issues like this that we are seeing over here. Okay, right, coming back. So okay, all right. See, before you can, try to control the, applications, it is important to understand the signatures used by these application control, right? Because once you have an understanding of how these signatures work, you would be able to easily understand, identify, and maybe configure the application control according to the requirement that you have, right? So again, understanding is quite um, mandatory over here. Okay, so let me ask you a question. So how does the application control detect the newest applications and changes to the application controls? Okay, so let me answer you that as well. Okay, so application control requires first of all a subscription to the Fortigate application control, right? So you have to have licensed device. Okay, your licensed device should have the application control feature enabled onto it. Okay, so the database for the application control signatures is separate from the IPS. Okay, the database, remember this, the database for the application control signature is separate from the IPS database. You can configure the Fortigate to automatically update its application control signature database on the Fortigate. Okay, the application control signature database information is only displayed on the Fortigate page. This is the only place where you will be able to know the version number that you can see. So can you see this red block? Application control signatures, and the version is 16. All right, so this is the only place where you will be able to get the information about the version. And again, the question rises that why do I need that? Okay, even if it is 16 or 18 or 20, how does it matter to me? See, it matters that you have to first of all check that what is the latest database which is running right now. Okay, and then whatever database that is running. So let's say, for example, you are maybe running, maybe on the internet, the latest application database is 20. All right, you are running 16, so you are -4 version, right? Now what this basically tells you is that if in case there is any update, any new kind of signatures which has been updated to the system, okay, you do not have that. And if in case those kind of attacks happens in your network, gone, your device cannot help you. All right, and basically the blame comes to the vendor that what happened, you were not able to update your device. That's the point. So always ensure that your updates are on a daily basis. And although if you look below system FortiGuard, you see that the schedule updates is daily, and it's 1 a.m. in the night, which is okay, but then I do not really suggest this. I normally go for every 6 hours to maybe 8 hours. Okay, see, it's not that every 6 or 8 hours there will be an update. Okay, but the point is that if in case there is an update, your firewall should be the first to get that value. Okay, let's say for example, just to give you an example over here, let's say for example at 2 a.m. there was an update. Okay, but your firewall took an update maybe in the 1 a.m. and it found out there was no updates. So now the firewall is basically waiting for 24 hours before you get the new update. All right, so from a security point of view, 24 hours is more than sufficient to do anything. If in case I mean there is a window, people who are willing to penetrate into that, they would be able to do it. So again, 6 hours and 8 hours is more than sufficient. So even if I have, let's say at 1 o'clock, let's say I tried testing, no updates, but then I'll try again in the next 6 hours, right? So the window that I would be having would be a lesser window as compared to a 24-hour window, right? So always make sure that your updates are on every 6 to 8 hours rather than on a daily basis. Okay. All right, coming back. See, this is what I was talking about, the application control database, right? So if you look closely over here, if you go to this particular website, okay, the fortigate.com, all right, you will go into the application control and you would be able to see all the kind of signature databases that you have. Okay, you can just have a look over here and see what is the the database and what it talks about, what exactly the description is, what is the reference value. We can get all these information. Okay, so just need to go visit this place, which is https://fortigate.com. Okay, go through it at least once and see what all information can you find over there. Okay. Okay, let's talk about the hierarchical structure. Okay, see, many web applications offer functionality that can be embedded in the third-party websites or applications. For example, you can embed a Facebook like button at the end of an article, or a reference or YouTube video on an educational website. It's quite possible, and quite possible. I mean, I would say this is very generic right now. Maybe a couple of years back, I would still say that okay, it was, you know, in the phase of getting to be well aware about in the entire network infrastructure, or in the WW or the World Wide Web, you know, maybe 8 or 10 years back. But today it's very easily available on all websites. I mean, a lot of people, a lot of websites, they have this embedded buttons. Now these buttons could be a like button, could be a post button, could be a share button, or something like that, right? So this is all about the the amount of embedding happening on a daily basis. Okay, give me 1 minute, guys. Okay, sorry, got a call from the office. Okay, coming back. So yes, hierarchical structure and embedding of the the like button and the Facebook share button, all that. Just to give you an example. Okay, all right. See, the 40 OS, or the 40 operating system, as we call that, gives administrators all the tools they need to inspect the sub application traffic. Okay, the FortiGuard application control signature database is organized in a hierarchical structure. This gives you the ability to inspect the traffic with more granularity. You can block Facebook apps while allowing users to collaborate using the Facebook chat. Okay, that was a definition. But then if you to make it very simple, understand that, let's say for example, that you as a firewall administrator is working on a daily basis, no problems at all. One of the one of the clients came up to you, and he said that, hey, you know what, I do not mind people accessing Facebook on lunch break, or maybe all over the time frame that they are in the office. I do not mind that. But if in case they are trying to post or maybe like something, I really do not want to do that. Okay, so can you do something about that? So now you, as a firewall administrator, that's your job to basically figure out a way that if in case the users are going to access anything on the Facebook, they're free to do that. But if in case they are trying to like, maybe share, or comment on something, they should not be able to do it. So again, application control basically comes to the rescue, where you have a lot of signature database, a lot of application control signatures, which are pre-configured in a way so that if in case something like this you need to apply, you can. Okay, so there are application control signatures for like button, share button, videos, Facebook chat, and Facebook comment sections, all those things. If you block those, people would still be able to access Facebook, no problem. But then the like and the comment and video option will not work for them. Okay, so that's the motive. That's how the system is designed so that you get that granularity. Okay, this is what you get if you're using the application control. Okay, let's take a quick Q&A. Okay, so which statement about the application control is true? One, application control uses the IPS engine to scan traffic for application pattern. Now guys, anybody who is basically going for the NSE4 examination, please remember this. This is absolutely necessary. Application control uses the IPS engine to scan the traffic. Okay, now which statement about the application control database is true? Application control database is separate from the IPS database. Do not confuse this. Application control uses the IPS engine, okay, but the database is different. Always remember this. Database is different, but the engine is the same. All right, come and go. Next. Okay, so application control profiles. All right, so all the security profiles that we are seeing, right? The the IPS and the web filter and the application control, though everything these are under the category of application. Sorry, these are under the category of profiles or security profiles, right? So when a Fortigate or maybe a virtual firewall inside the Fortigate is operating in the flow based, okay, mode, all right, or the flow based inspection mode, okay, or policy is basically set to proxy based inspection. Okay, now to configure the application control, administrators must create an application control profile and apply that profile to a firewall policy. That's simply understood, because whenever you are creating a security profile, you have to ensure that that security profile is implemented or called in the firewall policy itself. Only then it will be configured or it will be active. Okay, now it is important to note that the application control profile uses the flow based scanning techniques. I think we have already discussed that, right? That the application control uses the flow based scanning technique regardless of which inspection mode you are using on the policy. Okay, so always remember, application control works on the flow based mechanism. Doesn't matter if your policy is a flow based or proxy based, doesn't matter. Okay, all right, now application control profile consists of three different types of filters. All right, now let's talk about that. Okay, see, the filters or the types of filters that we have are one which is called as the categories. Okay, so categories is again, the groups of applications based on similarity. All right, so just like you have the web filter category, right? So if in case you have the social media category, then everything in the social media would come inside that social media. So Facebook, Insta, Snapchat and all that stuff would come under the social media. Same thing applies, or the same functionality applies with the application control category as well. Okay, next is called as the application overrides. Now this provides basically the flexibility to control specific signatures and applications. Okay, you can specifically tell that, okay, just look for this particular application signature, or just look for this particular filter. Okay, now you have something which is called as the filter override. Now filter override is useful when a predefined category does not meet your requirement and you want to block all applications based on the criteria that is not available in the category. You can configure the categorization of application based on behavior or popularity, protocol, risk, vendor, and I think there's one more. Yeah, the technology. So technology is also basically, I mean, you can take an action based on these kind of functionalities. Okay, protocols, vendor, or technology, behavior. These are the ways. These are the the filters that can be used for you to take an action. Okay, so when we are going to configure, you will be able to see all these options. Coming next point. Okay, Now see, this is the configuration part where you would be able to get to know the categories what we have, right? So let me zoom this up a little bit for you. Okay, so if you look closely over here, right, so you have the first category, which is business. Then you have the email, mobile, proxy, storage, VoIP. All right, so all of them are basically categories, and a lot of applications come inside these categories, right? So if you click on them, you can also click, there will be an option stating view signatures. Okay, so the view signatures would basically, you would be able to see all the kind of signatures that you have inside that particular category. Okay, so let's say for example, if I click on collaboration, for example, and I click on view signatures, okay, so I would be able to see all the signatures which is specific for the collaboration. All right, so any kind of, you know, online meeting sessions that you have, those kind of signatures will come under this category. Okay, all right. Okay, see the number listed to the right of the cloud symbol indicates the number of cloud applications within a specified category. Okay, so let me zoom this up. Yeah, see in this particular section, the general interest, you have 226, and then you have cloud symbol, and then it's 7, right? So basically there are 7 types of cloud applications which comes under the general interest category. In the P2P, there are none. In the social media, there are 32. In the video audio, there are 16. Okay. And if you go a little left, you see network services, which is 330, right? But then no cloud server, cloud infrastructure over there. All right. So these are this is how it is. You're able to identify that, okay, if it is cloud symbol, that means there are the cloud applications. Okay. This is the number of cloud applications inside that particular category that you have. Okay. All right. Now, if you need to, you know, enable, allow, or log DNS traffic, let me zoom out. Hold on. Yeah. See, if you need to, you know, enable the allow and log DNS traffic, you should enable it only for short periods, such as during an investigation, maybe some troubleshooting that you're doing. Okay. So depending on the application and how often it queries the DNS server, enabling this setting can use significant resources. Okay, this uses significant resources because a lot of your firewalls CPU and the memory utilization goes into this. Okay, so again, as I always suggest, if in case you are using this, okay, if you want to enable this option, make sure that you are maybe doing some investigation, maybe doing some troubleshooting with attack environment, or maybe doing your own investigation or troubleshooting. Okay, but then as soon as that is done, just do not disable this, because this is unnecessary utilization of your CPU and the memory. Okay, all right, next. Quick QUIC. See, this is a protocol from Google. Okay, instead of using the standard TCP connections for web access, Quick uses UDP, okay, which is not scanned by web filtering. Right now, allowing Quick instructs your Fortigate to inspect the Google Chrome packets for a quick header and generate logs as a quick message. Okay, now blocking Quick forces Google Chrome to use the HTTP TLS 1.2 and Fortigate to log the Quick as blocked. The default action for this is basically block. Okay, now this is required, or I would basically say that always make sure that you have this in the block category, because what happens is that if in case you're not doing this, all right, Google Chrome will start using UDP protocol. Okay, from a performance viewpoint, you might get a great speed, but then from a security standpoint, not a good place to be. Okay, because again, they'll start using the UDP, right? And then UDP FortiGate firewall basically will not be able to do a scanning or the filtering on it, because for web filtering to work and the application control to filter off the websites, it has to basically use the HTTP or HTTP, whatever the TS version it's being using. 1.2 is being the latest, but still you need that. So always make sure that your Quick is made to be blocked. Okay, Replacement messages for HTTP based applications. Always enable this. See, this setting allows you to replace blocked content, okay, with an explanation. So you might be, trying to access something on the HTTP that is blocked. So you'll get a, block web page. Hey, you know what? This is blocked as per the company's policy, blah, blah, blah. And you can get all those options over here. Okay. Okay. Protocol enforcement on HTTP and DNS port. Okay. All right. See, so protocol enforcement is added to the application control profile, allowing the administrators to configure the network services. For example, FTP, HTTP, or HTTPS. Okay, for known ports, maybe 20, 80 or 443. Okay, while blocking those services on the other ports. Okay, meaning that if you are enforcing this, basically this will make sure that if, let's say for example, you have some custom applications inside your network. Okay, once you enable this option, the applications will be forced to use the standard protocols, okay, which you have maybe 443 or 80. Okay, for an example, right? They won't be able to use the custom ports and protocols. Okay, now this the feature takes action in the following scenarios. See, for example, when the protocol basically when the or I can say when the application control engine confirms the service of the network traffic protocol, okay, it can check whether the confirmed service is whitelisted under the server port. If it is not, then the traffic is considered a violation and IPS can take the action, for example block for a specified configuration. Okay, there is no confirmed service for a network traffic. Okay, it would be considered a service violation if IPS engine rule out all the services enforced under its server port. Okay, now to keep it simple, think of it like if you have a network enforcement of maybe port 80. All right, so this basically means that whenever the scanning is done, okay, it will ensure that only this kind of protocol is able to pass through. Anything else, even if it is a HTTP protocol, but if it is using HT80 port, it will not work for you. Okay, it will only work if you have 80 port. Okay, so this is what it means, that if you have the enforcement in place, that you won't be able to use anything else apart from that. Okay. Right, so let's have an understanding of what is the order of scan. Okay, because the scanning order is very much important. So the IPS engine, okay, as we have already discussed, right, that the application control uses IPS engine, okay, examines the traffic stream for a signature match. Okay, now the Fortigate scans the packet for matches in this order for application control profile that you can see. Number one is your filter overrides, and then number two is the categories. Okay, so if you number one, so as the filter override, so if you have a configured any application override or a filter override, maybe a profile for protocols or whatever it is, right, it is going to check that first. That is one. Then would be the category. So if in case you do not have any filter override, so that is why you have the filter override at the first place, that you want to mandate, you want to prioritize whatever the override that you have. Okay, so if you have that, Fortigate is going to do scanning on that first. And if in case you do not have any kind of an override, then it will basically come to the category based system, and then according to whatever category that you have blocked, it is going to block that kind of traffic. Okay. So order of scan and blocking behavior. Okay, so consider this. See, the reason I'm basically doing this in such deep manner is because there are, again, we are basically working off with a evaluation licensed device, and not everything can be performed on a free license, right? So that is why screenshots, and behavior analysis and scenario based setups. Okay, but then it doesn't mean we won't be doing anything. We would be doing it, but then limited functionalities. Okay, coming back. So order of scan and blocking behavior. Scenario 1, what does it mean? Okay, see in the example, okay, the profile shown over here is that the application control profile blocks the game and the video audio categories, right? You can see that the game is blocked. Under that you have 84 signatures, and then you have audio and video, under which you have 155 with the 16 cloud-based signatures. Okay, all right. See, now for application in these categories, Fortigate responds with an application control HTTP block message, right? Now it is slightly different from the web filtering HTTP block message. See, all the other categories are set to monitor except unknown applications, which is allowed to pass, right? Let me just zoom this up so that becomes easy to look. Okay. All right. See, so what we are doing over here is every category, if you look over here, there is an eye symbol into it, right? There's an eye icon over here. So that eye basically means monitor. All right. And that red symbol basically means it is blocked. Okay. So everything else is monitor except the unknown applications, which is allowed. Okay. You see the green check mark, that basically means it's allowed. Okay. Now in the application and filter override section down below at the bottom, you can see that some exceptions are specified. Okay. Now instead of being set to block battle.net game and daily motion, which is video and audio, are set to monitor. Okay. So this is again an override where you are able to see that battle.net, which is a game. Okay. Now aside basically, but then it is allowed. Okay. Monitor. And then you have the second one, which is bandwidth filter, which is blocked. Okay. Now, if you look closely in the override section, okay, you have this filter override configured to block applications that use the bandwidth or excessive bandwidth. That's the filter. So for the first one is basically for the game. The second is a daily motion, which is video. It's fine. The second option or the second priority is being given to excessive bandwidth filter, which is blocked. Okay. Now see, it basically blocks all applications which are using excessive bandwidth, regardless of the categories that allow these applications. Okay. Now this basically shows an example of how several security profile features could work together, overlap, or work as substitutes on the same traffic. Okay. See, after the application control profile scan is done, the Fortigate begins another scan, maybe web filtering. Okay. So the web filtering scan could block battle.net and daily motion, but it would use its own block message. Okay. Also, web filtering doesn't check the list of application control overrides. So even if an application control overrides allows an application, web filtering could still block it. Okay. So this is, I'm just trying to basically tell you that this has happened in the past, that so one of the firewall policy that we have created, right? So we had IPS into it, we have application control into it, we have the web filtering into it. Now what happened was that because of certain misconfigurations in place and because of certain misunderstanding, there were a couple of websites and websites which was blocked, which are supposed to be blocked. Okay. Now what happened was it was blocked under certain security profiles, and it was allowed in certain security profiles. So what happened was abnormal behaviors. At times it was working, at times it was not working, and we were not able to figure out what exactly was happening, because the first thing which we used to do, or which we are supposed to do, is that look into the logs. Okay. Look into the firewall policy, find out whatever the firewall policy you have, find out what all the security profiles you have implemented, and then look into that specific information. So if I have IPS application control and web filter applied, I should basically see the application control, IPS, and web filter logs. But then again, because of maybe the situation and a couple of pressures coming in from multiple places, we kind of ignored that, and it took a lot of time to understand that where exactly the problem was. But my point over here is that if in case you have, if in case you are applying multiple security profiles, application control, web filtering, IPS, everything, just make sure that those three are in sync with each other. Okay, if any one of them are contradicting with each other, it may or may not work. Okay, there will be times that it will work, no issues at all. Once you have configured, maybe there is no issues, you are able to make it work as the way it is, it is required. But maybe after a day or two, or maybe after a couple of hours, it may start to behave oddly. Okay, so always make sure that whatever security profiles that you have, those are all in sync. Okay, so this has happened. That is why I normally consider this to be a part of the scenario. Okay, scenario 2. Okay, now look over here. In this example, you can see that the filter override has been moved above the application override. Okay, now the excessive bandwidth is at the top, and the battlenet and the daily motion is on the bottom. Okay, now what will happen is that the daily motion, falls under the excessive bandwidth category. Okay, so if you go and just look for the daily motion into so go to https fortigate.com. Okay, and search and put in dailymotion.com and enter. It will come up as a the excessive bandwidth category. Right now, daily motion is blocked even though it is set to monitor under application and filter override section. So the priority in which the application and the filter overrides are placed takes precedence. Okay, if it was vice versa, like in the previous example, okay, even though daily motion is a bandwidth consuming website, it would still be allowed. Why? Because the priority was 1 over there. Okay, look over here closely. You can see that in the priority section. All right, priority number 1, daily motion. Priority number 2, excessive bandwidth. So priority number 1 will be taking precedence right now. But in the scenario 2, you can see that the priority will be taken to the excessive bandwidth. Hence, now if you try to access the daily motion, although it is under monitor, you might be thinking that why is it not happening? Why is it not happening? But the problem is that your priority precedence is basically taking over. Okay, so very be careful about what is the preference, priorities, and the number of security profiles that you have in place. Okay, there are so many permutations and combinations that could potentially break your setup. Although you have configuring everything and everything is fine, but then if you have a lot of security profiles in place, make sure that all the security profiles are basically in sync with each other, complementing each other rather than contradicting each other, right? So this is very important. Okay, coming to the number of actions that you can have. Okay, so one is allow, monitor, block, and quarantine. Okay, so allow, it basically passes the traffic, but it will not generate any logs to it. Okay, monitor will pass the traffic, but it will generate the log as well. Okay, that's the difference. Block is going to drop the detected traffic and will generate the log as well. Quarantine will basically block the traffic from whatever IP it is coming, okay, until the expiration time is reached, and then it will generate the log message. Okay, so quarantine is like it's like if I quarantine a source IP. Okay, so maybe for an hour that IP is basically blocked from accessing anything inside the network as well as outside the network. Okay, and then it will generate the log message as well. All right, so the allow and monitor is basically a major difference, where allow does not log anything, monitor is going to allow but log as well. Okay, okay, now this is where exactly you go ahead and apply the application control in place. Okay, now you can see the deep inspection, right? See, after you configure an application control profile, you must apply it to a firewall policy that is there. Now this and basically instruct the Fortigate to start scanning application traffic that is subject to the firewall policy that you have, whatever is configured. Now deep inspection profile basically scans your encrypted traffic. Okay, so one is called as certificate inspection, one is called as the deep inspection. Deep inspection basically decrypts your traffic and look into the payload, because let's say for example if it is an HTTPS connection, right, normally you cannot basically look inside the SSL tunnel. But if you have the deep inspection in place, then your Fortigate firewall will be decrypting the traffic, decrypting the SSL tunnel, and then look into the HTTP payload, scan whatever IPS or application control that you have, and if in case the payload is fine, the data is fine, it would be allowed. And if in case something comes out to be malicious, it is going to drop the packet. That is what is called as a deep inspection. The block page. So this is how basically your block page looks like if in case you are if any of the website or anything which gets blocked because of the application control. Okay. Okay, now see what happens is for HTTP based applications, your application control can provide feedback to the user about why their application was blocked. Okay, this is called as a block page. Okay, now it is similar to the one that you configure for the URLs that you block using the Fortigate web filtering. It is also worth mentioning that if your deep inspection is enabled in the firewall policy, all the HTTPS based in application provide this block page as well. Now, if you think about it, if I have a deep inspection in place, by default, all my traffic will become HTTP traffic. Okay, or by default, every traffic I would be able to decrypt the packet and look inside the packet. Since I'm able to do that, I would be able to throw the block page as well. But if in case the deep inspection is not enabled, then I won't be able to throw a block page if it is a encrypted traffic. Okay, all right. Okay, so let's take a quick 3 minutes break. Okay, 3 to 4 minutes break, and then we'll start off again with the policy based. I'll go ahead and unmute you guys if in case you have any questions right now. And you guys are basically free to pick up a coffee or a break if in case you want, but we'll start off in 7:13. Okay, it's 7:10 right now. We'll start off by 7:30. Free to ask any questions, no problems at all.
IPS and application control has a different signature. I'm not able to understand what actually the help application control is taking from IPS.
It's the I think so when we say that we have the different database, but the application control uses the same IPS engine. What it means is that it may see it's okay, I'm giving you a very lame example, but see if you have a pressure cooker in your kitchen, right, you can use it to cook your rice, you can cook your pulses into it as well, right? Again, scenario is different, but you're using the same utensil, right? Same thing over here as well, that the engine is the same, the IPS engine is the same, but the utilization is a little bit different. Now, what's the utilization? See, if I want to maybe block some audio files and video files, I'll probably go for IPS. But if I want to block maybe some certain aspect of the application, maybe posting a video or uploading a video, downloading a video, a file, like button, share button, something like that, then I'll probably switch over to the application, because I cannot use IPS to do all these things. Okay, that's the difference.
So once the IPS engine identifies the application, what is then the next role for the application control signature or
See,
data?
it's actually vice versa. It's so what happens is whatever application control that you have configured, so whatever security profile that you have configured. So let's say, for example, your client says that here, what, I don't want anybody to go into the YouTube and upload any video or maybe like any video. Let's say this is the situation. So what you'll do is you'll go into the application control, configure the YouTube section, you'll search for YouTube, you'll get all the YouTube signatures. In the YouTube signatures, you'll block the YouTube video upload and YouTube like button. Once you do that and apply it to the firewall policy, the application control or the IPS engine now will try to filter out the traffic which is based on those signatures. Any signature that matches the upload video signature, or any signature that matches the like button, okay, it is going to block that kind of traffic. That is how it works. So you configure and then the engine becomes active. Okay. And if in case you still have an IPS into it, maybe IPS, you have configured an IPS to maybe block anything which comes from Linux machines. Okay. So you're using the same IPS engine, but the functionality would be a little different. If in case there is any traffic which matches a Linux traffic, it is going to drop that. But then if in case anybody else from a Windows machine is trying to upload a YouTube video, that will also be blocked. Both of them are using the same IPS engine, but the functionality is different over here. Does that answer your question or still doubt?
Still I doubt. See, my question is like IPS has identified the application. Now, why it was not blocked just only with the IPS? Why we are checking for the application control signature after that? Because the IPS has identified the application. Okay, maybe it's a YouTube. So why we are taking the help from the application control? Is there any?
It is again. See again. So there was the reason it is application control, because these whatever we are trying to do over here, when downloading, blocking a download video or upload video, like or share or whatever it is, right? This is all application based signatures, right? It has nothing to do with the IPS. Yes, we are using the IPS signatures. Okay, the signature is basically under the same engine, but we have divided the category. It is just for the, see, it could be very much maybe under the IPS, that you have two parts to the IPS. One is that if in case you want to block anything, maybe Windows or Linux, you go to part 1, and then if you want to block anything which is maybe upload or download video, you go to part 2. But what they have done is, rather than saying it as part 1 or part 2, they have divided it to two categories. One is basically pure IPS, where you allow a block on the basis of maybe vendor or technology, and then you have the application control, where you are allowing or blocking the traffic on the basis of whatever application filter that you are using or application signature that you have. Okay, you are using the same engine, but then the categories are different to make it simple for the firewall administrator to understand that, okay, this comes under the application control and this comes under the IPS section. You are using the same IPS engine. It's just that they are categorizing it differently. Still doubt?
Okay.
Yeah. Still not getting it? You can basically tell me. That's frankly no problem.
No, I got it. But my only doubt was like, see, identification is done with the IPS. Then
right.
Why we are using
application?
We can still block it with the help of IPS also. So like, what is extra there in IPS which we want to take a help? Because see, identification is done by IPS. Now IPS has found the application. Now IPS can also block it because IPS also has signatures. Like the only question is why, like what is extra is there which is not in.
No. See, so couple of years back, I'll tell you, with 5.2, so we are as of now working with 7.0, right? With 5.2 firmware and 5.4 firmware, there was no separate databases for it. So so now I'm telling you, right, couple of times I think I told you that IPS engine is same, but database is different. Application control database is different. IPS database is different. But with previous version, there was no difference at all. They were using the same database. They were using the same IPS engine. It was just that. So take this reference with the central NAT, right? We can apply the firewall. So we can apply the NAT inside the firewall policy, right? And if I want to enable the central NAT, I can enable the central NAT, and then I get the NAT option separately apart from the firewall policy, correct? Same thing applies over here as well.
Actually, I'm not aware of central NAT because I asked this like you told you will be covering central NAT.
No. My point is that central NAT is you can see the central NAT differently. You can see the central NAT as a option apart from the firewall policy. I'm going to cover up that. My point over here is that think of it like, have we covered the firewall policies, right? Do you know how to configure the address objects? Yes. Yes, no?
Yes.
Yes. So there are two ways to configure the address object. One is you can go into the firewall policy and then click on the source or the destination, and then click on the address object, and then you have the option to create a new address object, right? That's one way of creating the address object. The other way is going under the address object section and then create an address object over there, right? They're the two ways. You know both ways, right?
Yes.
Right. Now the same thing applies over here as well, that rather than the IPS and the application being two different things, they are basically the same thing. With the previous version, there was no difference at all. The only difference is that you are showing them under different category. That is it. That is the only difference between both of them. There's nothing special which is happening apart from that. It is just that they have categorized it differently so that you can basically, whenever you know that okay, you have to basically allow or block something which is specific to the application, then you will go under the application control. But if in case you have something which is the vendor based or technology based or something like that, you come under the IPS. They both are using the same functionality and the same feature. It is just they are categorized differently under different names. That is it.
Okay. Now got it.
All right. Okay. So moving forward now. Okay. So the next generation policy based mode. See, the next generation policy based mode, what does it means is that it's available in the flow based inspection mode. Okay. The application control is configured directly on the security policy. Okay. I'm going to show you that. Give me a second. So yeah. Okay. See, when a Fortigate is operating in this NGFW mode, okay, the administrators can apply the application control to a security policy directly. Now, instead of having to create an application control profile first, then apply that to a firewall policy, eliminating this need to use an application control profile makes it easier for the administrator to select the application or the application category they want to allow or deny in the firewall policy. Now, why do we need that? Why? I mean, we already have one way of doing it. Why do I need another way of doing it? See, the reason is that if in case you have a server farm, okay, and you want to apply the firewall as closely as possible to your firewall, your server farm. Okay. In that case, this kind of setup is basically called as a next generation firewall setup. Okay. You do not call that firewall as a UTM firewall. UTM firewall is basically a firewall which is like a firewall which is placed between multiple LAN segments, and anybody who's going out on the internet will be scanned through this particular firewall. Then you call that firewall as a UTM. You call a next generation firewall a firewall when you are applying that particular device closer to your server farm and then IPS and application control are being used simultaneously, and it is not an option, it is a mandatory option. There you use this mode, which is called as the next generation firewall mode or the next generation policy mode, where applying an application control or an IPS is a mandatory option. Just like in a firewall policy, can you create a firewall policy without any source or destination? Can you? No, right? The same thing applies over here. If I have the next generation firewall mode enabled, this basically means that I would be able to, I would have to make sure an application control is enabled and certain signatures are enabled into it. Only then I will be able to use that particular mode, or I would be able to create a firewall policy. Otherwise, I won't be able to even create a policy for that matter. Okay. Yeah. See, this is what I'm talking about. So when you are creating a firewall policy, this is how it looks like. You'll have the source, incoming interface, outgoing interface, and all that stuff. But adding to it, where you would be also allowed to add the application control. Okay. See, you can select one or more applications, application groups, or application category on your security policy in the application section. Now, after you click the plus icon for an application, a pop-up window opens. Now, in that window, you can search for or select one or more application signatures or application group or category. Now, based on the application groups or application categories applied to the policy, the FortiOS or the Forti operating system applies a security action to the traffic, whatever you have. Okay. Now, you can configure the URL category as well within the same security policy. However, adding a URL filter causes the application control to scan application only in the web browser technology category. Okay, for example, Facebook Messenger on the Facebook website. Now you can also configure the group with multiple applications and application categories. This allows the administrator to mix multiple applications and categories. Now, in addition to applying a URL category filter, you can also apply the antivirus and IPS security profile. You are given that option. Okay, but I would suggest that if in case whenever you're using this kind of a setup where your Fortigate firewall is basically acting as a next generation firewall closer to a server farm, I would suggest you to use the the application category URL, not so much so, because that may cause you problems. Okay. Now, how does this thing work? How does the policy, next generation policy, works for us? Okay. See, the FortiOS or the Forti operating system, it uses a 3-step process to perform this next generation firewall or the NGFW policy based application. Okay. All right. See, the step 1 is that the operating system or the Forti operating system will allow all traffic while forwarding packets to the IPS engine for inspection and identification of the traffic. At the same time, the FortiOS will create an entry in the session table, allowing the traffic to pass, and it adds a may dirty flag. Okay, so you see this, the may dirty flag. So may dirty, although it's part of NSE4, but then may dirty is basically means that your firewall is basically instructing that this particular traffic needs to be scanned again. Okay, so how does this thing work? One is that the FortiOS will allow the traffic while forwarding the packets to the IPS engine for inspection and identification of the traffic. Same time, it will add a entry in the session table. Okay. Step 2, as soon as the IPS engine identifies the application, it updates the session entry with the following information: dirty flag or app valid flag. Okay, and an application ID. Okay, so this is added because it identifies that this information or this traffic is basically part of this application and all that stuff. So it's going to add that particular flag as well. Step 3 is the FortiOS kernel performs a security policy lookup again. Okay, now to see if the identified application ID is listed in any of the existing security policies, This time the kernel uses both layer 4 and layer 7 information for policy matching. Now, after the criteria matches the firewall policy rule, the FortiOS kernel applies the action configured on the security policy to the application traffic. This is how the NGFW policy based filtering works. Okay, first allow the traffic and allow a session table entry. Okay, and add the may dirty flag to it. Step 2 is IPS engine is going to identify whatever application it has. It will add the dirty flag, the app variant flag. Okay, and in the third option, the kernel will basically go and again check the security, again scan the traffic and check for the information, that whatever information that has been identified, is it right or not. Okay, but this time it will basically go from layer 4 till layer 7 for policy matching. Okay, this is so it's like the same traffic is basically scanned twice. All right, that is why it is ensuring that whatever the traffic is, it is malicious free and has the right information, has the right application identification, right signature, right flag and everything. Okay, so if whenever you see may dirty, you might get this question in the exam. Whenever you see may dirty, it means the traffic will be scanned again. Okay, this was a question in NSE4. There are chances that you may get this question. If you see may dirty, it means there will be an option. It will basically say that, does it mean that the traffic will be scanned again or not? Okay, so traffic will be scanned again. It will have the right identifications and all that stuff. That's important. Okay. All right, now configuring the app control in the policy based. All right, so you can basically filter out whatever applications that you have. You can just select that particular application and then apply that. So if you say YouTube, it is going to find and it's going to figure out whether the traffic that you are going through or it is scanning, is it YouTube or not. If it is not YouTube, it is not going to allow the traffic. If it is YouTube, it is going to allow the traffic. Okay. Central NAT is again, I'll probably, I'll probably do one thing. I'll probably club this up tomorrow with the practical so that you will be able to do the NAT as well as the application control. Okay. Okay, now this is important. So let me zoom this up. Hold on. Okay. See, the next generation firewall policy matching works using a top to bottom approach. Okay. And it's not just with the NGFW, it's basically for how every firewall policy basically works. It's always from top to bottom. Okay. Now you must have a specific policy above a more broad or an open policy. For example, if you would like to block Facebook, but allow the social media category, you must place the policy blocking the Facebook traffic above the policy which is allowing the social media. Okay, because that is common sense. Because if I have a, let's say for example 10.0.0.0/16 and allow, okay, now I'm beneath this policy I have 10.10.10.10 and I'm blocking everything. It will not work, because from top to bottom approach, it is going to take up the first one, which is the /16 subnet, and it is going to allow the traffic. Same thing applies over here as well, that if you want to allow the social media category but block Facebook, then the Facebook category firewall policy should be on the top, the social media category should be on the bottom. The crux of the matter is that all the crisp and restricted and whatever the policy that you have, which is very much specific, very specific to allow, very specific to deny, very specific on the application, very specific on the IPS or whatever it is. If it is specific, always be on the top. If it is very, very generic or very open, it should be at the bottom. Okay, that is the basic standard. If in case whenever you are creating a firewall policy, doesn't matter what vendor that you are working with, Palo or Checkpoint or Fortigate, this is always supposed to be the case. If it is specific, move it on the top. If it is generic, move it on the bottom. Okay. application control traffic shaping. So traffic shaping, I think we discussed it maybe in the initial time, I mean today's session, that traffic shaping is basically kind of a bandwidth control, all right, where you are telling your FortiGate firewall that how much bandwidth should be given to whatever category of application that you are allowing. Okay. Okay, so if an application is necessary, but you must prevent it from impacting your bandwidth, right? Then instead of blocking it entirely, you can apply a rate limit to the application. So for example, you can create a rate limit application used for storage or backup, leaving enough bandwidth for more sensitive streaming applications such as video conferencing, right? So applying a traffic shaping to the applications is very useful, but you are trying to limit the traffic that uses the same TCP or UDP port number as mission critical applications, right? Now some high traffic websites, such as YouTube, can be throttled this way, right? So examine the details of how throttling works. See, not all the URLs request to www.youtube. Okay, so what basically you can do is that your browser makes several HTTPS connections. One could be for the youtube.com, one could be for the images, one could be for the scripts or Java template, or maybe some URLs for the video. So there can be multiple URLs, or although on the front page you might just see youtube.com, right? But you see 16 tabs or 18 thumbnails with different videos. So those are all URLs. At the back end, those are all URLs. Okay, see, so all of these items basically have separate URLs or sub URLs for that matter. Now if you analyze a site like a youtube.com, the web pages themselves don't use much bandwidth. It is the video content. I mean, we all know that, right? It's not the web page which is having the content, it's the video which is having the content. Now that uses basically most of your bandwidth. But since all the content is transported using the same protocol, which is HTTPS, because youtube.com is basically everything is on HTTPS, right? And the URLs contain dynamically generated strings. So those strings are basically called as what do you call them? Alphanumeric. Okay, so these are called as alphanumeric strings. Now traditional firewall policies can't block or throttle the traffic by the port number or the protocol, because they are same, right? Everything is going on HTTPS connection. Yeah, so using the application control, you can rate limit only the videos. Okay, now doing this prevent users from saturating your network bandwidth, because what happens is, if let's say for example you have 100 users, right, 100 of them are basically watching YouTube videos, your network bandwidth will get choked up, right? So what you do is you apply this traffic shaping or bandwidth control, so that you are limiting the number of video content, or limiting the number of bandwidth that can be consumed by the YouTube. Okay, while still allowing them to access the other content on the site, such as maybe the comments or the share and all that stuff. Okay, those will be available, but the video section will be restricted. Okay. Okay, now let's understand this configuration part of this. Okay, see, you can limit the bandwidth of an application category or an application group or a specific application by configuring the traffic shaping policy. You can also apply the traffic shaping for to the FortiGuard web filter category, to the application group. Okay, again, it's up to you that what kind of traffic shaping you want and where on what policy you want to apply that. So you must ensure that matching the criteria aligns with the firewall policy or the policies to which you want to apply shaping. It does not have to match outright. I mean, for example, let's say if the source in the firewall policy is set to all, okay, and you can set the source in the traffic shaping policy to any source that is included in all, for example, local subnet. Okay, so what you are basically doing is that you are allowing only a part of the all section. Okay, oh, sorry, hold on. Okay, so if the traffic shaping policy is not visible in the GUI, you can enable it on the feature visibility. Now that is by default. If you want to enable the traffic shaping, it needs to be enabled under the the feature visibility. Okay, now there are two types of shapers that you can configure on the traffic shaping policy page. Okay, one is called as the shared shaper and one is called as the per IP shaper. Okay, now the shared shaper is basically applies for a total bandwidth to all the traffic using the shaper. The scope can be per policy or for all policies referencing that shaper. Okay, so basically when I say shared shaper, basically it means it will be applied to everyone. Per IP shaper applies traffic shaping to all the source IP address in the security policy. Bandwidth is equally divided among the group. Okay, so per IP basically means to a specific policy. Shared shaper basically means it will be applied to everything. Okay, now let's take up a small Q&A. So which statement about the application control in the NGFW policy based configuration is true? So applications are applied directly to the security policies. Absolutely correct. Which statement about the HTTP block page for application control is true? It can be used only for web applications. Okay, so if you are obviously if you're using HTTP block page, then it will only be used for the web applications, right? Because HTTP itself is web based. Okay. All right. Now what is left is basically the configuration part of this, which I'll be taking up tomorrow. All right, now in the configuration part we are going to basically use the application control to block certain signatures. Okay, and see how the logs are getting generated, how and what options do you get. And we have already discussed about the situations and the scenarios today, but with the lab we'll see what all options can we use, how do you configure, how do you identify the signatures, how do you log the traffic, and what could be the best practices with that. Now just remind me tomorrow that with this I'll also add the central NAT part to it, so that you would be able to configure the application control not just with the default policy but with the central NAT as well. Okay, questions any with respect to what we have discussed today? Before I'll finish up the session, any questions or doubts with respect to the application control? Because tomorrow will anyway start off with the practicals.
RV, I have a is Fortigate is a subscription based.
Right.
It's not a freebie, right?
Yeah. Right.
Oh.
Security profiles, any security profiles, antivirus, web filter, application control, IPS, everything. These are all, licensed based features. Okay. All right. Okay. All right. So if we do not have any further questions, we can stop the session for today. And tomorrow we are going to meet up same time, but for the practical. So be ready with your EVNG setup and make sure that your lab is ready. Okay, we are going to do the practicals tomorrow. Yes, Sunit, question?
Yeah, are we not related to this? Can you help like how to prepare for NSE4 examination?
I've shared some documents.
Yes, okay.
Just make sure you drink those documents.
Okay.
Just drink them up and pester me as much as you can.
Where did you share that?
It's in the drive.
It's in the drive, yeah.
Oh, okay.
Take that. So so specifically there are two documents with respect. So there's something which would be like Fortigate security, and then you have something like Fortigate infrastructure. Yeah, so find find these 2 documents and drink those documents. Literally drink those documents as much as you can. Okay. And even if one line you are not able to understand from those 2 documents, ping me whenever possible. I'll try to make it easy for you guys. All right. So that is very much required, very much necessary if you are going for the certification. All right. If in case you want to just make sure you are brushing up your knowledge on the Fortigate firewall, making sure that you are ready for the interview for the Fortigate, live sessions are more than sufficient. But if in case you are preparing for the certification, then I would say, drink up those documents, and that is all that you need, nothing else. Do not need to worry about anything else, any other documents, any other thing that you have to basically download from the internet. Those 2 documents are more than sufficient. That is it. Nothing else you require. Just make sure that you go through that. Yes, Kalpesh.
That file name is Fortigate infrastructure and Fortigate security.
Yeah, these 2. Yes. Make sure that you go through these 2 documents. Security first, that is part 1. Infrastructure is the second part of it. Okay, that has a lot of information as compared to from the live classes, but then my point is that go through them. If in case anyone is basically preparing for the certification, that is more than sufficient. Okay, and if in case you feel like you're not able to understand something from that document, do let me know. I'll try to make it simple enough. Okay.
Given NSE4, which because there are many, which one you have given?
I've given couple of months back. I was on 6. It was on 6.4.
I think there are many exams in.
Yeah.
You can choose one, or it is like you have to clear all.
No. So with NSE4, you basically, so there's no there's no options with the NSE4. You can just go with the NSE4. But now 6.4 from FortiOS, I think, I'm not sure though, but then they will be removing it real soon. 7.0 will be the one which will be used for examination now. So if in case you want to prepare for that, this is the document, which is NEC 7.0. So go through them. NEC 7, you have multiple certifications in that. So NEC 7, you have to search for enterprise firewall. That is Fortigate firewall. NEC 7, then you have SD-WAN, which is entirely different, which I completed, I think maybe a month or maybe 2 months back. I'm not really sure. But SD-WAN is entirely different. It basically includes your Forti Manager, Forti Analyzer, Fortigate Firewall, and the SD-WAN into it. Okay. Very different, but NEC 7 is basically having multiple certifications. NEC 5 also have multiple certifications, which is Forti Manager, Forti Analyzer, and a couple of more devices into it. But if you know the firewall part from the NSE4, that is like that will open up a lot of doors for you. And if in case you need to know maybe manager and analyzer, those are not primary, but if in case you know them, it's good. It's like you will be considered. If in case you do not know manager and analyzer, you will still be considered. But if in case you know that, yeah, maybe like an added advantage to it. NEC 7, if you know NEC 7, if you have cranked NEC 7, great. I mean, nothing like that, because NEC 7 again, it's like a mixture of CCI, but it has a lot of CLI troubleshooting, a lot of CLI troubleshooting. We do not really use much of the GUI over there. A lot of CLI troubleshooting, one-to-one debugging, whatever commands that you execute, every line of the debug output that you get, you should know the reason behind that. So that is the level of or that is the depth of knowledge that it's been tested on. So quite difficult. But then if in case you guys are preparing for NEC4, probably I'll say give it about a month after the live classes are done. Give it about a month practicing the the lab environments and going through that documents. That should be more than sufficient. And if in case anybody is preparing for the NEC4 certification, do let me know. I'll probably give you some I'll tell you some ways of going through Q&As, what kind of Q&As will be coming in. Okay, so that it will basically help you with the getting to know about the the feel of how the questions are, how they try to turn off the same logic, but they try to confuse you with those things.
I'll get in touch with you because I'm planning for NSE4.
Okay.
Yeah, I'm also
Thank you.
planning.
You're also planning. Okay. So I'll probably, share those websites with you, but then not right now, because maybe once you are 80% done with the live classes and the documentation, I will probably share those. So it's like once you prepare all these things, then go for like a Q&A session. Okay.
Thank you.
Alrighty. Okay. So Daman says, can I do a separate session on the NSE4 exam? Yeah, I can. What I'll do is once we have, once we complete at least 80% and only few topics are left, maybe 2 or 3. All right, then I'll probably take up another session just to, help anyone who is basically preparing themselves for the NSE4 examination. So I'll help you how to prepare, what are the the ways to prepare, and what to be done, what needs to be done, what kind of labs to done, and all those things. Okay. And once this is all done, then probably a couple of websites that I'll share, go through them and do a lot of practice, do a lot of questions, and that is it. Yeah, yes, but then those are like brushing up at the end. But these 2 documents, you have to drink these documents. I cannot overemphasize on this as much as I can. Okay, drink them up as much as possible. Okay, all right. Alrighty, so I'll see you guys tomorrow, 6 o'clock, and we'll start off with the practicals of application control. Okay, all right, guys. See you tomorrow. Bye-bye.
Yesterday.
Yeah, Sunit, yeah.
Yeah, actually, I am having the 6th version hard copy of these books. So is it too much difference, or I have to go for
no, don't go for that.
Okay.
There are a lot of difference to it, and then there's no point because it doesn't cover a couple of topics which is required for NSE7. And now whenever, see, anyway, you'll take about a month or 2 maybe. You're not going before Feb, right?
Right.
Yeah. So anyway, the certification will be 7.0. So it doesn't matter if you're going with the 6th version. It won't make any sense.
Okay.
It's always better to use the latest one.
Thanks.
Yeah, no problem. Okay. All right, guys. See you tomorrow. Bye.